So once we have the reactions found, again, what I like to do is just maybe put a little X or whatnot, a little tick mark through the members that the problem asks you to find, and that a lot of times that's going to be pretty much where you make your cut. So I'm going to cut the truss in this case in half, all right, and I'm only going to use 1/2. So maybe in this case I'm going to use the left side. Okay, so I'll wipe away sort of the right side of the truss. Now the members that I cut, these become basically unknown forces. They really become unknown joint forces. All right? Okay, so now you have a section or a new free body that looks like that. Again, right side of the truss, since we've cut it sort of in half, sort of goes away. All right? When you look at that truss, again, that AD force is diagonal. We've already identified that that angle from horizontal is 50.2 degrees. But, you should really think of that AD force as being made up of a X component and a Y component. Okay? So, even though we're interested in AD, you might be thinking of AD in terms of its components. So, like I said before, when you start going through this just mentally, you might take a look at the unknowns and just sort of make a mental note. How many X unknowns do you have? 3, right? CD, the component of AD, and then AB. So while you could write an X equation right off the bat, and there's nothing wrong with that, you're not going to solve anything right away. If you look at your unknowns and you ask yourself, hey, how many Y unknowns do I have? What would your answer be? 1. Hey, 1 unknown, that sounds like if I write the Y equation, I'll be able to solve for it right away. So why don't we start there? Some forces in the Y direction. Again, I got to include the other forces that are on this new free body that I've created. So I got plus 400, that was a reaction. I got the minus 1,000, that's the load up top. And the way, again, I've always drawn these forces acting away from the joints or away from the cut. So in this case, I'd have a positive AD sine of that angle. Okay? So I can combine the plus 4,000 minus 1,000, that's minus 600, plus AD sine of that angle is equal to 0. I can take the 600 on the other side where it will become a positive. Okay, and then I can divide through by sine of 50.2 degrees. And when I do that, I will find out that the force AD, which is really a joint force, is what?
780.96.
Okay, I call it 781. All right, 781 in this case. These were pounds, so 781 pounds. Now, it did come out to be a positive, right? So that positive means right direction, and as we've talked about before, that's going to mean tension. Okay, so AD is 781 tension. We'll erase these components. Although they're still there, I'm going to erase them just to clean this up a little bit. All right? So, now what do I want to do? I still have CD left. I still have AB left. What would you say I might want to do right now? How about some moment at A? By some moments about A, which one of the unknowns goes away? AB. Which one of the unknowns is going to be in the equation? CD. So some moments about A sounds pretty good. All right? Some moments about A, you also lose these reactions that occur at A. You lose AB, you lose AD, you lose that 1,000 pounds that comes down. So all those things cross through A, so we don't have to worry about them causing moments about A. So I do have the 500 pounds that acts, this is a 12-foot distance, right? 12 feet away. And it does go clockwise, so in this case I'll call it, positive. I do have CD, which is 12 feet away. That's also going clockwise. And that's it. That's my moment equation about A. You could solve this real easily. I mean, what you're going to do, this is 6,000. It becomes a negative 6,000 on the other side. Divide through by 12. And lo and behold, CD comes out to be a negative 500. Now what does negative mean? Compression. It also means the arrow or the force goes the other way. Okay? So this is, I'll put negative 500 up there, but because I always draw things acting away, if it comes in negative, the answer comes out to be negative. That means compression, going back in. All right? So we've got 2 out of 3 unknowns solved for. How are we going to solve for AB? Huh? Well, we got choices. We could do the X equation now if we wanted to do that. We could also sum moments up here about point. What's that point? Point C, I guess. All right, I've got this as being AD. This is really AC here. Sorry about that. That's really AC. I had AD written up there, but it's AC. So what do you want to do? An X equation? Or you want to do a moment equation?
X equation.
Okay, you want to do an X equation? That's fine. Either one will work. Okay. Some forces in the X equation. Okay. I'll write the X equation first. Like we don't know anything. So we have plus CD, we have plus AC. Sorry about that. I had written AD up there. This diagonal is AC. AC cosine of 50.2 plus AB. I do have these 500-pound reactions, or the 500-pound reaction, and also the 500-pound force. So I'll say minus 500 plus 500, and all this stuff would equal 0. Okay? Well, the minus 500 plus 500, that sort of goes away, right? Okay? CD, I found out that was a minus 500, right? I already solved for that, and I found out it was a minus 500. I already found that AC was 781. Now again, I got to take cosine 50.2 plus AB is equal to 0. What's 781 cosine of 50.2 degrees? 781 cosine 50.2.
499.9.
So basically 500. Okay? So I've got, now check this out. I've got minus 500 plus, which is essentially 500, okay, plus AB equals 0. What's AB going to be equal to? Zero. I mean, at 499.9, we've read off, so that's basically 0. So AB equals 0. Okay? So again, You got your answers there. CD is 500 compression, AC is 781 tension, and AB is 0.